Okay, sorry I started the recording too late, but what we just did was a review of number 1 from 5.5. So if you don't remember how to do that, go back to the last video and watch that. We're just building off of law of sines today. And we're starting by recognizing that all the problems we did yesterday were angle, angle, side. Here they're angle, side, side, which is something called the ambiguous case. It's called the ambiguous case because there's one of 3 answers that we could have. One answer is that there are 0 triangles. It's not true. There's no way for us to make any triangles out of the information I gave you. The second option is for us to only have 1 triangle. And then the third option is for somehow for us to have 2 triangles that are true from the 3 pieces of information I give you. I believe back in geometry, I had a cute little visual for you. Something like this. Okay, I don't know. Let's say I had a triangle like this. This is a little acute triangle. All my angles are acute. This could be 1 triangle. If I only gave you angle A, angle AB, or sorry, side AB, and then side BC, we could have this cute little acute triangle, or we could have an obtuse triangle like this. The reason this works is because angle A is still the same in both the blue and the purple blue and pink triangle. AB are still the same, and then BC would be the same if I moved C in here. I'm just going to move him out so you can kind of see the 2 different triangles. So I'd have this cute little acute triangle, or I could have this big obtuse triangle where angle C is obtuse, not acute. If that's the case, then the pink angle C, that's not what I wanted to do. The pink angle C and then this blue angle C would be supplementary to each other. And so if I start solving this problem and I find out that we could at least have 1 triangle, I need to check and see if its supplement, this obtuse angle, would make it okay to have a second triangle. So once we do our law of sines, we're going to do 180 minus the angle that we get to see if there's a way we could form a second triangle. Okay. Again, there's 3 different options. So I've got 3 examples here, and I'm going to do 1 of each example. Now, if I didn't tell you that there could be an ambiguous case, you would have just started solving this like we did yesterday, and that's how we're going to start. We're going to solve it the same way. We're just going to keep in the back of our head that there might be an issue and that we need to be careful. So I'm going to start by drawing my picture. Any little triangle, I've got A, B, C. We know angle B is 82. We know side little b is 17, and I know side little c is 15. Okay, I know I can do sine of 82 over 17. And then the only other thing I can find next is angle C, because I can do sine of C over 15. I can't minus from 180 to find angle A. I can't do Pythagorean theorem to find little a. I have to find big C first. So I'm going to do sine of 82 over 17 equals sine of big C over 15. Okay, cross multiply. I'm going to do 17 sine C equals 15 sine 82. I'm going to divide by 17 on both sides. Which gives me sine of C equals 15 sine 82 over 17. I'm going to use my calculator. So that's why my calculator was up. I'm going to use that. So 15 sine 82 divided by sine, or just divide by 17. And I get 0.8738. I like to round as much as possible. You may not feel the need to. In order to get C by itself, I have to do second sine or inverse sine to the -1 of the decimal I just found. You don't have to write all these steps as I do, but I want you to kind of know where I'm going and not just writing random stuff. So I'm going to press second sine of the answer I just got, and I get 60.1. or sorry, 60.9. If you do any rounding, that's okay. You might just be off like by a couple decimal points from me. Just kind of keep that in mind, and I will keep it in mind to look at your work if your answer is not quite exactly what I have. Okay, if I had not prefaced this whole page by saying there was an ambiguous case, you would have been like, oh, la-di-da, let me go put in for angle C, 60.9. All right, cool. Now I can subtract to find angle A, find BC, blah, blah, blah. What I want to pause and say, okay, this is my little acute triangle. We have to check to see if there's an obtuse triangle. I need to do 180 minus 60.9 to see if I have a second type of triangle. That triangle would look something like this. I don't know, some acute triangle, where I'd have to have 82. If this is A and this is B and this is C, angle B has to be 82. And then angle C is the supplement 180 minus 60.9, the supplement of the angle I just found, which would be 119.1. And we have to use our knowledge of a triangle to see if there's like enough angles left for angle A. You know that the sum of a triangle is 180. So I'm essentially asking myself, if I do 82 plus 119.1 plus something, is that going to equal 180? Some of you already are looking at it and you're like, there's no way. Something over 100 plus something over 80 will not equal 180. There won't be room enough left. So if I were to actually do it out, if I didn't, have the spidey senses that it would work, 119.1 plus 82 is 201.1. There's no way that I can add something to that and still be in my parameter of a triangle. So this doesn't work. That means that there cannot be an obtuse triangle. The first triangle I had works. This guy's good. I'm good here. Like, we're going to keep solving him, but I do not get to do this option of an obtuse triangle. So I'm going to say in this case, there's only one triangle. There's only one triangle I can make when given this information. It does say solve it, so we do need to solve the one triangle that works. So I'm going to finish using my law of signs to find A and little a, but I don't have to worry about the second triangle because that one doesn't work. Does anyone have any questions on that? Okay, let's keep solving. So I'm going to do 180 minus 82 minus 60.9, and that's 37.1 for this angle right here. Again, I did 180 minus 60.9 minus 82. And then now I need to do law of signs to find that. So I'm going to do the two angles that were given to me, or the angle that was given to me, 82 over 17 equals sine of 37.1 over A or X. I'm just going to do it in here. So sine of 82 over 17 equals sine of 37.1 over A. A times sine of 82 equals 17 times sine of 37.1, and then divide by sine 82. 17 times sine of 37.1 divided by sine of 82 equals 10.4. All right, and then now I know that I'm done because I've solved everything. I found all of the sides, I found all of the angles. We have found everything in this triangle. And again, I tried to find a second triangle, it didn't exist. The minute I got an answer right here, the first time, I knew it couldn't be 0 triangles, so I looked to see if it was 1 or 2. We're going to do an example momentarily if there's 0 triangles, but if you get an answer, you at least have one. You have to check and see if there's a second one. Any questions yet? All right, let's do another one. The next one, A is 73, little a is 24, little b is 28. So let's draw this triangle out. A, B, C. Big A is 73, little a is 24, little b is 28. 28, yeah, I said it right. All right, again, we're in the ambiguous case, but our first step is the same as if we had two angles in one side. It's just law of sines. Sine of 73 over 24 equals sine of b over 28. Cross multiply. 24 sine b equals 28 sine 73. Divide by 24. So sine of b is going to equal, let's see, 28 sine of 73 divided by 24. Okay, 1.12. All right, any questions so far? I haven't found b yet. I just found sine of b. So now I need to do second sine this number I just found. So I'm essentially doing b equals inverse sine or second sine or sine to the negative 1 of 1.12. Ooh, did anybody else get an error? Did you get a problem on your calculator? Because I did. My calculator says not a number. I don't know what your error message looks like, but you probably got like your calculator flipped out and they're like, wait a second, this can't happen. When that happens, that's okay. That means that we have no triangles. There are 0 triangles here. If you get an error or like a doesn't exist or something like that, that means that there's no way for this set of numbers to make a triangle. If one of my angles is 73, one of the sides is 24, and one is 28, we cannot have a triangle. If you get an error message, that's not true. A cool thing, and again, I know you probably weren't doing pre-cal over spring break, but if you were thinking about it, if you remember sine, our sine graph before our little curve, it only went as high as 1 and as low as -1. So I actually was a little suspicious as soon as I got this 1 point something, something, something. That's bigger than my range for a normal sine curve. So I was suspicious, and then we got an error message, and I'm okay with that because there's no way, there's no angle that's going to have a sine bigger than 1. That's not how this works. All right, so we did an example of only one triangle where we got an answer, but then the supplement didn't work. So that was only one triangle. We did an example where we didn't even get an answer. So that means that there are 0 triangles. As I'm sure your context clues are about to lead you to believe, we're going to do an example now with 2 triangles. So we're going to see, just like the first one where it works, but then instead of crossing out my obtuse triangle, we are going to find that. So let's draw our triangle. Let's do our first step. Let's see what our first angle is. All right. You can draw your triangle however I am trying to prove a point. So I tried to take a little bit of care with mine. I've got little c is 32, little a is 18, and then little c is 10. There's only one option, only one thing we can do first, and that's to find angle A. So I'm going to do sine of 32 over 10 equals sine of A over 18. You guys have gotten good at solving for law of sines. So I'm going to do 10 sine A equals 18 sine 32. Divide by 10. (18 sine 32). Divide by 10. Okay, so this time I'm going to do my inverse sine or my second sine of 0.9538 or 39, I guess it doesn't really matter. Second sine of my answer. And I get angle A is 72.5. Okay, so I know it's not 0 triangles because I got an answer. So I now have either 1 or 2 triangles. So I'm going to go put this in this picture, 72.5. Okay, what I have to check, I am going to have to finish solving this. I'm going to have to find angle B. I'm going to have to find little b. But before I do that, I'm going to check and see if I could have a triangle that's not this cute acute one, but an obtuse triangle, something like this. Just making it look a little bit nicer. This purple triangle I just drew on top, if I take it out, my C is the same. My C would still be 32. My little a would still be 18, and then my little c would still be 10. But my angle A is not going to be 72. It's going to be 180 minus 72.5. I want to see if its supplement works as an obtuse angle. So let's see what angle that is. 180 minus 72.5 is 107.5. Okay, so now I have 2 triangles. I know the top one's going to work because 32, 72.5, they're definitely going to add up to 180. I need to see though, do I have enough room for another angle at B? Does 32 plus 107.5 plus something equal 180? The last time the angles that I had were too big. This time 107.5 plus 32 is only 139.5. That leaves me enough room to have a third angle in this triangle. 180 minus 139.5 is 40.5. So I actually can have this purple triangle where my angles are 32, 107.5, and 40.5, just like I can have the blue triangle above where my angles are 32, 72.5, and then something else I'll have to find out momentarily. Does anyone have questions on why we see that these 2 triangles work? Now that we see that there are 2 triangles, we do need to finish solving them. So you need to find all of the angles and all the sides before we're done with this problem. Let's actually finish this purple one first because all I'm missing is this side, little b. So I'm going to do sine of 32 over 10 equals sine of 40.5 over little b. Do that over here off to the side. Sine of 32 over 10 equals sine of 40.5 over b. Cross multiply. And this is all like the work we did yesterday, so we should be pretty familiar with this one. Ten sine 40.5 divide by sine 32, 12.3. So that means this little side right here is 12.3. And now I have everything on the second triangle. I've got both, all 3 of my sides. I've got all 3 of my angles, and we could fill that out in a nice chart if we wanted to. I have to finish the first triangle though. Go back to this blue triangle. I can easily find angle B by just doing 180 minus 32 minus 72.5. And I get 75.5. And that is not the same color. Oh, well. And then I'm going to do another law of sines to find little b. So I'm going to do 32 sine of 32 over 10 equals sine of 75.5 over b. I'm going to zoom in to solve that. B sine of 32 equals 10 sine of 75.5. divide by sine of 32. 10 sine 75.5 divided by sine of 32, 18.3. Again, I've got all three sides and I've got all three angles, so that's how I know that I am done. I had to do 3 different law of sines here. The first one found my angle. Then I had to see if I had a second triangle. And then my last 2, one was to find one side on the second triangle, one was to find the missing side on the first triangle. All right, any questions? I want to go over to the next side and just do one problem, one more word problem. Number 3 is pretty simple. And that will just leave us number 4 and then law of cosines at 5.6 when we come back in person. Any questions before I move on? Okay. Oh, go ahead.
Like when you decide if it's 2, do you just do the biggest angle, 180 minus that?
You do 180 minus the angle you just found. So whatever angle we like just found, not the one that was given to us, the one that like we found from the first step.
Okay, thanks.
Good question. All right, this word problem says that we've got 2 observers, points A and B, that are 2.32 miles apart. They see a hot air balloon directly between them, but the angles of elevation are different and they're shown on the figure. We want to find the altitude of the balloon. I even gave us the answer here, so we're just confirming the answer. Altitude means the height of the balloon. And we're going to use just normal sine, cosine, or tangent. We're going to use a normal trig function because we've got a little right triangle. But before we do that, we need to find out one of the missing sides. We can either find this distance or we can find this distance. It doesn't truly matter. I'm going to do this one, little a. I'm thinking about this big triangle as a whole, and I'm going to do law of sines. This is just like the problems I gave you yesterday. So we have to find this missing angle first, and then we're going to use it to do law of sines. I can easily find that angle by doing 180 minus 28 minus 37. And that's 115. So 115 is this angle. And so I'm going to do sine of 115 over 2.32 equals sine of 28 over A. Sine of 115 over 2.32 equals sine of 28 over A. Cross multiply, A sine 115 equals 2.32 sine of 28. Again, this is a lot like the work we did yesterday. Divide both sides by sine 115. 2.32 sine 28 divided by sine 115. My side A, so essentially the distance between point B and the hot air balloon, is 1.2. So I can think of this as 1.2 miles. Now, I don't want to know that distance, and I also don't really want to know this distance. What the problem is the vertical distance, the height, the altitude right here. I'm labeling that a little h, height. So I'm going to use this little right triangle and just do normal trig functions. I've got an angle, I've got its opposite, and I've got its hypotenuse. So if we remember SOHCAHTOA, we're doing sine because we're doing opposite, which is h, over hypotenuse, which is 1.2. Sine of 37 equals h over 1.2. 1.2 sine of 37 equals h. Plug and chug. Whoa. And height equals 0.7 miles. I know I did that pretty quick, but it was just a basic law of sine and then a basic trig function. So we combined two skills together. And then the one underneath that number 4 that we'll get to when we're in class together again, next time, it's very similar to this. So we'll go over that process again. Anyone have any questions? All right, I'm about to email you your quiz. I need you to submit it to Schoology. There's a little Dropbox just called quiz. So just upload it when you're done. You can use your notes, you can use your calculator. I'd like it done by 3 o'clock. You should have plenty of time. And if you need anything, let me know. You're welcome to stay on Zoom or you're welcome to leave.